Section 3.3 Complexity of Algorithms. In this problem, we are asked to find a theta notation in terms of n for the number of times the statement x equals x plus 1 is executed in these lines. X equals 0 for I from 1 to n, x equals x plus 1. Solution: for each value of I from 1 to n, the line x equals x plus 1 is executed once. So the answer is the function f of n is equal to n, which is of theta notation theta of n, of course. The next example, find theta notation in terms of n for the number of times the statement x equals x plus 1 is executed in the code. And here we have x equals 0, and then for I equals from 1 to n, for I equals from 1 to n, x equals x plus 1. For each value of I, starting from 1 and continuing up to n, the inner loop is executed n times for each value of j from 1 to n. So the answer is the function is n squared, and its theta notation is, of course, theta of n squared. Third example, find the theta notation in terms of n for the number of times the statement x equals x plus 1 is executed in this code. Solution: for each value of I from 1 to n, the inner loop is executed I times. So the number of times the inner loops is executed is this sum. It is the sum of the numbers from 1 to n, and this is n times n plus 1 over 2, which is a polynomial of degree 2, and its theta notation is comes from the leading term. So theta of n squared. The last example, divide and conquer. In this code, we have x equals 0, I equals n, while I is greater than or equal to 1, and this is the action. X takes value x plus 1, I takes value the floor of I divided by 2. Find the f of n, where f of n is the number of times the statement x times x takes value x plus 1 is executed. First we consider this case when n is 7. We can write 7 as sum of powers of 2. Any positive integers can be written as a sum of powers of some powers of 2. 4 plus 2 plus 1 is 7. In binary notation, we have only digits 0 and 1, and 7 is written as 3 ones in binary. the first value of I is 7, and this line is executed once. Then I takes value, the floor of 7 divided by 2. But 7 is written this way. When you divide by 2, you get this. 2 plus 1 is an integer, so the floor of this number is just 2 plus 1. 1/2 is less than 0. Less than 1, greater than 0. 2 plus 1 in binary notation is 1 to 1s. So what happened is that the last digit of 7 in binary disappeared after the first run of the while loop. Next, the line x takes value x plus 1x executed the second time, and then I takes value 1 plus 1/2. This is the floor of 3/2, which is 1. Line 4 is executed, this line 4 is executed for the third time. The next value of I is the floor of I divided by 2. That is the floor of 1/2, which is 0, and the while loop terminates. So the answer is 3. And 3 is just the number of binary digits of 7 in binary system. We can write these computations in this table. The first value of I is 7 in binary, and the next in the first round I takes value 1 in binary, and then 1 in binary, and then 0, and the loop terminates. Similarly, if n is 10, we can write 10 in binary as 2 plus 2 cubed, so it is 1010 in binary. And for each execution of the action of the while loop, one binary digit again disappears, and we get 4 executions, so f of n is 4. In this case, 10 is between n 8 and so 10 is less than greater than or equal to 8 and less than 16. Any number n, integer n, in this range will have 4 binary digits, and f of n will be 4. In general, if n is between 2 to the k and strictly less than 2 to the k plus 1, then the number of binary digits in n is k plus 1. That is, f of a is k plus 1. Now, applying the logarithmic function to the base 2, which is denoted this way, LG. And you see LG, it means logarithm to the base 2. Apply this function to these inequalities because this function is increasing. We have k less than or equal to logarithm to the base 2 of n, strictly less than k plus 1. because k is an integer, k is just the floor of this real number. And k plus 1 is the floor of logarithm of n plus 1. So f of n is the floor of logarithm of n plus 1. And the theta notation of this function is logarithm of n.